right, we're on to page 10. Thermal energy is energy of heat. It is transferred through a substance by collisions of atoms within the material. So same thing we didn't talk about. It hits something, that constant hitting. Even if you're doing this with your hands, you feel your hands start to get warm because they're hitting. Atoms are the smallest unit of matter that composes all physical substances. Makes up everything. Essentially, thermal energy is energy of moving particles or those moving atoms. Remember, atoms make up everything. Even a solid is vibrating. So if they're hitting, that's how they're passing the energy. You've learned many ways in which heat energy can be transferred. So how does it occur? The energy of moving particles is moved from one substance to another until all objects are equal in terms of thermal energy. Equilibrium. They want to be balanced. So if you have a scale and you have, apples and oranges, and maybe you want to get the scale balanced, well, then you have to maybe add another apple to get it balanced. Same thing with heat. Heat is going to continue to leave your body, to leave whatever, the hot chocolate, the hot coffee, until it's the same temperature as the air around it. It wants to be in equilibrium. It doesn't want to feel warmer or colder. So it's, constantly giving away its energy. And remember, our bodies run around 98.6 degrees. So the air around us is usually colder. So that's why your body's constantly giving off heat. And on especially cold days, it's one thing to give off more heat because, 98, 30s, your body's trying to get to equilibrium. That's why if you wear a jacket, you're keeping your heat inside you and not letting it go and feeling cold. Remember, there's no such thing as cold. Happens until all objects are at an equilibrium, a balance or equality between both. Sorry, I don't. After you turn a stove burner off, it eventually cools down to room temperature. It doesn't stay warm. It's not like, oh, magic. No, it keeps giving off its heat until it's the same temperature as everything around it. Where does the heat energy go? It's released to the surrounding air, and it spreads then into the atmosphere. There's two methods of heat transfer. There's conduction and convection. Conduction is transfer of energy through direct contact. Okay, key thing here is this word duct, like duct tape, right? Conduction, you have to touch for it to contact. That's a stovetop. You touch the stovetop, you're gonna get burned because it's hot and you're touching it. How heat usually travels through solids. So when it's going from a solid to a solid, if you touch a hot stove burner, the heat is transferred to your hand by conduction. Your hand's a solid, the stove's a solid. Two solids touching. Convection is circular energy through a liquid or a gas. Circulation of heat in fluids. Fluids are both liquids and gases. Example, warm air rises, cold air sinks, or boiling water. We also have talked about the example of convection in the earth. Hot magma rises, cold magma sinks because that hot magma can rise and go this way. So now you're getting a divergent boundary because the magma's pushing the crust apart. In a pan, it's constant. So you have hot water down here. It's going to rise. And then this cold is going to come down. And it's going to warm up. And it has to get even hotter than the hot water. So then it rises. So then you have the hot water. And it has to get hotter than the hot water. And then it rises. Then you have hot. And it keeps going and it keeps going in this circular motion until you reach 212 degrees. That's the boiling point. So it's constantly having that changing effect until that happens. How can you see a difference in thermal energy? Is it possible to complete the activity on page 11 to find out? Page 11 deals with glow sticks. We have a video to watch. We'll either watch it in class or I'll post it on Google Classroom so you can watch it and look at those things of how, if you open a glow stick, break a glow stick, would it change when it's in regular water, cold water, and hot water? What's going to make it burn brighter? What's going to make it last longer? Those are things that this page 11 kind of answers. All right, have a good one, y'all.